Hello students, I welcome you to today's session. Today is the last session for theory of machines and we'll quickly cover up three chapters today: gyroscope, balancing, and cams and followers. Right? In the same order, first we'll go through gyroscope, then we'll go through balancing, and then we'll go through cams and followers. Okay? So let us start with gyroscope. So here I've written the definition of a gyroscope, right? What exactly is a gyroscopic torque or couple, right? And what is a reactive gyroscopic torque or couple, right? But to understand this definition, first we'll have to see, we must have some visualization. Only then we'll be able to understand, right? The first thing that we need to know in this chapter that there are three axes here, right? One is the axis of spin. One will be the axis of precision, about which there will be an angular acceleration, and there is a third axis, perpendicular axis, will be known as axis of gyroscopic couple. Right? Let us try to understand. Okay, let us try to understand all these 3 points. Okay. Now you can see in the figure. Okay, you can see in the figure. Right. This is a rotor. What is this? This is a rotor. Right, it could be anything. It could be an aeroplane, it could be a ship, and right, it could be anything. For example, let me say this is a aeroplane, let me say. Okay, you'll have a rotor inside the aeroplane, right? The rotor will be rotating. It could be a propeller. In fact, it could be a propeller, right? Whatever it is, right? But this is a rotor which is rotating. This is a rotor which is rotating. Okay, so this becomes ox becomes the axis of spin. What is ox? Ox becomes the axis of spin. This is the first axis we are talking about. Axis of spin. The first axis becomes the axis of spin. Okay. Now, the next axis we are talking about is the axis of precision. Let me say the aircraft. Okay, let me say this aircraft, it made a turn. It had a turn. Okay, it made a turn. It was in this position initially. Then suppose it's had a turn towards left. Okay, it turned towards left hand side, towards left, right? So basically, if you see this, if it is turning towards left, right, about which axis, right, this turning is going on, it is about OZ. The turning is happening about which axis? It is happening about OZ, right? So basically, OZ is the axis about which the axis of spin is turning. This is the axis of spin. The axis of spin had a change in its direction about which axis? About OZ. So the next axis we are concerned about is OZ. The next axis we are concerned about is OZ. It is called axis of precision. It is known as axis of precision, right? So you can see these two axes are perpendicular to each other, and the third perpendicular axis, the third perpendicular axis, the third perpendicular axis, this axis, that is OY. Axis OY is the axis about which the gyroscopic couple will act, right? So it is known as axis of gyroscopic couple. Torque or couple. Axis of gyroscopic couple. So this is what we are going to see. Okay, let us first understand there are three axes here: axis of spin, axis of precision, and axis of gyroscopic couple. Right? Okay. So now let us get a little bit into detail. Okay, let us get a little bit into detail, okay, to whatever extent it is possible. Okay. So initially the rotor was rotating, say, in this direction. So if you see from front, you'll get to see this direction as anti-clockwise. And if you see it from this side, anti-clockwise. If you see it from this side, right, If you see it from this side, it will look like clockwise. It will look like clockwise. So how to determine the direction? So we determine the direction of angular velocity, couple, right, angular momentum, or you say angular acceleration, all using right hand thumb rule, right? So we'll determine the right hand thumb rule. We'll determine the direction of angular velocity by right hand thumb rule, right? So what exactly right hand thumb rule says? It says that curl your fingers of the right hand in the direction of the angular velocity. For example, if you're seeing it from, let me say, this side, from O, right? If you're seeing it from this side, okay? Then curl your fingers of your right hand in the direction, means in clockwise direction. The direction of thumb will represent the direction of angular velocity. So if you do it, you'll get to know that the direction of angular velocity is this. This is the direction of angular velocity from O to say A. Right? Direction of angular velocity of the rotor. Direction of angular velocity of the rotor. So you have to do it practically and see, right? Even if you're looking from the other side, even if you're looking from the other side, no issue with that. Even if you're looking it from this side, there is no issue with that, right? You just use the right hand thumb rule, curl your fingers in the direction of rotation, right? The direction of the thumb will represent the direction of the angular velocity. Curl your fingers of right hand in the direction of rotation. The direction of your thumb will represent the direction of the angular velocity. So OA is the direction of angular velocity, right? Now after some time, okay, after some time, this axis, this angular velocity is also rotating about another axis, that is OZ, that is the axis of precision, right? Say in small time dt, let me say in small time dt, the axis of spin rotated by angle delta theta, right? Let me say in small time delta t, the axis of precision rotated about say delta theta. Then we can say angular velocity of precision. What is omega p? Omega p is angular velocity of precision. Angular velocity of precision. This will be is equal to delta theta by delta t. It will be equal to delta theta by delta t, right? So after some time, you can see, as you can see, the angular velocity changed its direction from OA to OB, right? Initially this was OA, you can see O, let me say A, and it changed to OB. The angular velocity changed from OA to OB. By how much angle? Let me say delta theta, right? Okay. So in which direction is the angular velocity, angular acceleration? I can say the angular acceleration acted in direction from A towards B. The angular acceleration, will be from A towards B. Angular acceleration is from A towards B. From A towards B. So how to determine the direction of angular acceleration? We'll just do the reverse, right? We'll use right hand thumb rule, but we'll do it reverse. Point your thumb in the direction of the vector. So vector is from A to B. So point your thumb in the direction of the vector, that is from A towards B. Point your thumb from A towards B. Then curl your fingers. So if you curl your fingers, you'll notice that your fingers will curl in this side. Your fingers are curling this side. So this is the direction of angular velocity. This is the direction of angular velocity. So if you see it from A side, if you are looking at this velocity from A, if you're looking at this velocity from A, suppose you're looking at this velocity from A, right? So you will see this as clockwise. If you're looking the same velocity from B, you'll see it as anti-clockwise, right? You'll see it as anti-clockwise. That is why we use the right hand thumb rule. That is why we use right hand thumb rule. So what is AB? AB is the direction of acceleration. What is AB? AB is the direction of acceleration, right? AB is the direction of acceleration. Now, for this acceleration to happen, we know that there has to be a torque, right? For this acceleration to happen, we know that there has to be a torque. So this torque, A to B, this torque is also known as active gyroscopic torque. Active torque from A to B, it is known as active gyroscopic torque. So what is this torque responsible for? This torque is responsible for angular acceleration from A to B, right? So torque is from A to B. That is why angular acceleration is from A to B. So this is the basic funda first need to understand. For the axis of spin, we know this was the axis of spin. Which was the axis of spin? This is the axis of spin. Axis of spin, right? To change its direction, right? Some amount of angular acceleration is required. The angular acceleration is from A towards B. About which axis this angular acceleration is happening? About the axis of precession, right? Let me set a speed of omega p. Right? Then in the third axis, we have the gyroscopic couple, right? In the third axis, we have the gyroscopic couple. Yes, we are going to see this. Right? So this is the active gyroscopic torque, which is actually producing the angular acceleration from A to B. Right? Definitely, for angular acceleration to happen, there has to be a torque, right? There has to be a couple, and the couple that is acting from A to B is actually causing this acceleration, and it is named as active gyroscopic couple. Now, every action, we know that by Newton's third law, every action has equal and opposite reaction. So if there is an active gyroscopic couple, there has to be a reactive gyroscopic couple. If you have an active gyroscopic couple from A to B, you'll have a reactive gyroscopic couple exactly equal in the opposite direction, right? So active gyroscopic couple, you have seen it is from A to B, and you can use the right hand thumb rule, right? So you can see the direction is clockwise if you see it from A, right? So the reactive gyroscopic couple will be opposite, that is from B to A, or you can simply say B dash to A dash, D dash to A dash. This is the reactive gyroscopic couple. Reactive gyroscopic couple. Reactive gyroscopic couple. From B dash to A dash, you have reactive gyroscopic couple by Newton's third law of motion. Right? Newton's third law of motion. Right? So what is the direction? Again, you will use the right hand thumb rule. Point your thumb from B dash to A dash. Right? And curl your fingers. If you curl your fingers, you'll get to see that your fingers are curling in this side, right? If you see that your fingers will be curling in this side. So in that case, if you see it from A dash side, you'll get to feel as if this is anti-clockwise. If you see from B dash side, the same vector, same rotation, if you see it from B dash side, you'll feel that this is clockwise, right? So it matters from which direction you are seeing. So the reactive gyroscopic couple, you can see the direction of the reactive gyroscopic couple is this, right? And the magnitude of the reactive gyroscopic couple, the magnitude of the gyroscopic couple, you can say. Then you can prove this, but I'm not doing it because of lack of time. The magnitude of gyroscopic couple, the magnitude of the gyroscopic couple is represented by C is equal to I omega omega P. I omega omega P. So what is I? I is the moment of inertia of the rotor. Moment of inertia of the rotor. What is omega? Omega is the angular velocity of rotor. Angular velocity of rotor. And there is one more term, that is omega p. What is omega p? That is the angular velocity of precession. Angular velocity of precession. Okay, so there's three terms. Now, in this question, the question that will be framed from gyroscope, right? They will have two parts. One is the numerical part and the direction part. One will be numerical part and the direction part. So numerical part is easy. You can see the formula is very easy. I omega omega p. You have to calculate omega omega p I. Then you have to multiply. That's it. Okay. The only thing that will trouble you is the direction. Okay, we are going to learn. We'll do a problem and learn it. But before that, let us go back to the definition. Now let us go back to the definition and let us try to understand what does the definition say. Right. So if the axis of spin of a rotating body is given an angular acceleration about another axis perpendicular to the axis of spin. Right. So there is an axis of spin. There is an axis of spin, and this axis of spin is given an angular motion about another axis perpendicular to the axis of spin, right? So axis of spin, this is the axis of precession. Axis of precession, this is axis of spin, right? OX, as you see, is seen in a diagram. OX, axis of spin in which the rotor was rotating, So this is given an angular acceleration in a perpendicular acceleration. So this is axis of precession, right? So in that case, an angular acceleration x on the body about third perpendicular axis. Which one is the third perpendicular axis now? An angular acceleration x about a third perpendicular axis, right? The torque which is responsible for this angular acceleration is called active gyroscopic torque. Right, the torque which is responsible for this acceleration is called active gyroscopic torque. Is similar to the concept of centrifugal force and centripetal force we have studied in circular motion. A reactive inertial gyroscopic torque will act on the body. Right, so if you have there is a active, then there will be reactive force which will be act on the body, right? And this reactive gyroscopic torque is called gyroscopic couple. It is called gyroscopic couple. I think now you will better understand this. Now I think you will better understand this. Okay. So let us do a problem. So very simple here. Very simple. There are two things. That you need to do here is first you have to find out the value of gyroscopic couple, that is I omega omega p. This is rather very simple to do, right? The second thing is the direction. Okay, direction of reactive gyroscopic couple. Direction of couple. Right, so that has to be done through an analytical method, right? There is no formula for that. Analytically you have to understand this concept properly, then you'll be able to do it. Okay, let us try to go through this question. Okay, the rotor of a turbojet engine of an aircraft has a mass. So mass is given and a polar moment of inertia. Okay, polar moment of inertia is given about the rotor axis. The rotor rotates at a constant speed of 1100 radian per second in clockwise direction from when viewed from the front of the aircraft. The aircraft, while flying at a speed of 800 km power, takes a turn with a radius of 1.5 km to the left. Right. So all the data are given to calculate the gyroscopic couple. Let us first calculate the gyroscopic couple. देख लेते हैं, ठीक है? What is the value of I? I is given as, what is the value of I here? What is the value of I given? Value of I is given as 10. What is the value of omega given? Rotor rotates at a constant angular speed of 1000, so 1100 radian per second, 1100, right? And then you have the axis of precision. The velocity is given, linear velocity is given, radius is given. So the angular velocity of precision will be 800 divided by 1.5 kilometer. You have to convert it into meter per second. So this is 1000 divided by 3600 divided by 1500. So if you do this, your answer will be, let me see, 10 into 1100 into 800 into 1000 divided by 3600 divided by 1500 is coming out to be 1629.62. So 1629.6 Newton. So definitely the answer is going to be among B and C. Definitely the answer is going to be among B and C. As I said you, the numerical part, calculating the numerical part is not hard. It is the direction part that is definitely going to cause a concern. Okay, देखते हैं. Let us try to find out the direction. Okay. Now, the rotor rotates with a constant angular speed of 1100 in the clockwise direction as viewed from the front of the aircraft, right? So, if I see the aircraft, let me say this is the aircraft. Let me say this is the aircraft. So, these are the blades, tail, and the wings of the aircraft, right? So, now, if you see it from the front, what it is saying, if you see the rotation from the front, it seems like that it is rotating in clockwise. Clockwise matlab aisa kuch hoga. So now use your right hand thumb rule. Right hand thumb rule, curl your fingers in the direction of rotation. The direction of thumb will give you, curl your fingers of the right hand in the direction of rotation. The direction of the thumb will give the direction of angular velocity. So if you see this, the angular velocity will be in this direction. This is opposite to what we have seen it in our theoretical concept, right? So let me say this is OA. Let me say this is OA. Now it takes a left turn. Now the aircraft takes a left turn, as it is said, turns to the left. The aircraft takes a left turn. So if the aircraft takes a left turn, my dear, let me say this is the new direction of the aircraft. So you can see that the angular velocity will change its direction from that to this. This will be the new direction of angular velocity. So in which direction angular acceleration took place? Angular acceleration is from A to B. Means active gyroscopic couple is from A to B. So in which direction is the reactive gyroscopic couple? Can I say the reactive gyroscopic couple will be opposite to from B towards A? Right? From B towards A. So if the reactive gyroscopic couple, that is the gyroscopic couple, is from B towards A, then in which direction? Can I say, using again right hand thumb rule, point your thumb in the direction of the vector, right? And curl your fingers. You'll see that your fingers are curling in this direction, right? Your fingers are curling in this direction, right? So this is the reactive gyroscopic couple. This is the reactive gyroscopic couple. So what is this reactive gyroscopic couple trying to do? Reactive gyroscopic couple. So what is this reactive gyroscopic couple trying to do? See, this is the aircraft. If this is the direction of reactive gyroscopic couple, so what it is trying to do? It is trying to put the nose down and it is trying to put the tail up, isn't it? You see it clearly. You see it clearly. Okay, what is the reactive gyroscopic couple trying to do? Again, let us see it. This is the direction, right? This is the direction. So if you see, if in this direction, the gyroscopic couple X, so what it is trying to do, it is trying to put the nose down. So what will be the answer? The answer will be B, 1629.6 Newton meter, and the nose goes down. I hope you are able to understand this. Okay, now we will be doing the new chapter, that is balancing. Now, often an unbalanced force is produced in rotating or reciprocating machinery due to the inertia forces associated with the moving masses. Balancing is a process of designing or modifying machinery so that the unbalance is reduced to an acceptable level, and if possible, it is entirely eliminated. A particle of mass moving in a circular motion experiences a centripetal acceleration, right? And a force is required to produce it. An equal and opposite force acts radially outwards on the axis of rotation, which is also known as centrifugal force. This centrifugal force is a disturbing force on the axis of rotation, the magnitude of which is constant, but the direction constantly changes with the rotation of the mass. In a revolving rotor, the centrifugal force remains balanced as long as the center of mass of the rotor lies on the axis. Now, this is the main point, right? As long as the center of mass lies of the rotor lies on the axis, the centrifugal force will remain balanced. But when the center of mass does not lie on the axis, or there is an eccentricity, an unbalanced force is produced which causes serious problems in high-speed machineries. It is there in almost all rotating, right? It is not possible to manufacture a machinery with the center of mass lying completely at the axis of rotation. For example, we have steam turbines, rotors, the engine crankshafts, rotary compressors, centrifugal pumps. Everywhere there will be some unbalance of the other, because the center of mass of the rotating elements will not completely lie on the axis of rotation. It doesn't matter how much good designing you have done, but there will be slightly small unbalance is always there. And even if it is not there initially, with time, when there is a wear and tear, right? So what will happen? Automatically, after some time, after some uses, the center of mass will actually go out of the axis of rotation. So this might cause many serious problems, especially in high-speed machineries. These forces will be exerted on the frame of the moving members, right? So it will produce vibrations and noise, discomfort to the uh, human beings will be caused, and also there will be detrimental effects on the machine performance, right? The structural integrity of the machine foundation will slowly get weak because of the vibrations. So we have to balance that unbalanced force. That is the main criteria of this chapter. The most common approach is by redistributing the mass, which is accomplished by addition or removal of various machine members. We are going to see, we are going to have an outline how exactly we are going to do balancing. Now, balancing, there are of two types. Now, balancing, there are of two types. What are those? Balancing can be of reciprocating masses, or the balancing can be of rotating masses. Just hold on. Balancing can be Balancing, if you're talking about balancing, it can be for rotating masses. Also, it can be for reciprocating. Also, it can be for reciprocating masses, right? Rotating masses, for example, where you notice this kind of balancing problem. So even if you see, the aeroplanes, right? You have rotating masses in aeroplanes, right? You have rotating masses in aeroplanes like the turbine rotor, right? Or the propeller or whatever, right? There is enough rotating masses in an aeroplane, right? But reciprocating masses are not there. Earlier used to be there when earlier used to use genome engine, that is radial engine, right? Radial engine, it consists of many reciprocating masses. So earlier that was used, but radial engines, yes, they used to produce very good thrust, but it also causes to increase the weight of the overall aircraft. So that is why nowadays radial engines are not used. Nowadays, what kind of engines are used generally in aircrafts? There are two major engines, either turbojet, turbofan, and you have the propeller engine, turboprop. Okay. Generally, the commercial aircrafts you get to see, right? The Boeings, Airbus, whatever. Generally, what we fly, right? They're using the turbofan engine. They're using the turbofan engine. If you see the fighter planes, right? Whichever fighter planes India has, right? India has a MiG series, Sukhoi, right? The newly built LCA Tejas, right? Now Rafale has come, and there are a lot many other fighter planes, right? Most of the fighter planes, if it is employing a jet engine, then it is going to be turbojet, not turbofan. Otherwise, there are some passenger carrying vehicles also, right? They are using turboprop engine. So all the aircrafts will have some amount of rotating masses. All the aircrafts will have some amount of rotating masses. So rotating masses, rotating balancing of rotating mass is much more important for us. If you see reciprocating masses means in which generally in IC engine, or you can say reciprocating compression. If you have similar kind of, if you're using similar kind of reciprocating engines, then definitely balancing of reciprocating mass will be required, especially in IC engine. This is a very important point. In all our vehicles, be it two-wheeler or four-wheeler, we are using a reciprocating engine. So it becomes very important for us to balance the reciprocating engine so that there is less amount of discomfort, noise. That is very primary issue, right? Better is the comfort, more is the value of the car, more the car will sell, right? Longer the distance the passengers will be able to travel. Now, there is one definitely one concern. The second concern is the integrity of the structure also. If there is a lot of vibration, the vehicle will very soon break down. The servicing required will be much more. Okay, but in today's lecture, we will not be doing balancing of reciprocating masses. I hope you have understood why, because it is not very important with respect to HLXL. Yes, but definitely we are going to do the balancing of rotating masses. Now the rotating masses, there can be of two types of balancing. What is the static balancing? Static balancing, and the other one is uh, dynamic balancing. Static balancing and dynamic balancing. So in static balancing, we are just concerned about rotation of masses in one plane. In dynamic balancing, we are concerned about rotation of masses in more than one plane. In static balancing, we require only one formula, that is sum of all the forces. Sum of all the forces should be equal to 0. In dynamic balancing, it is not just about sum of forces equal to 0, but it is also sum of moment about 0. That is what we are going to see. There is not much theory involved. There is not much theory involved. So we'll just understand some of the points from where the questions can be asked. Then we will do a numerical each from static balancing and from dynamic balancing. So it will help us in understanding, right? The first is static balancing. A system of rotating mass is said to be in static balance if the combined mass center of the system lies on the axis of rotation. This is what already we have talked about, right? So if you see here, there are three masses M1, M2, M3. If the combined center of mass lies on the axis of rotation, there will be simply no problem with respect to balancing. You can say the system of mass are in static balance, right? So in that case, what will happen? Summation of force will become equal to 0. If the system of masses is in static balance, the summation of force will be equal to 0. Now, you might be thinking, what kind of force? What I'm talking about is centrifugal force. What I'm talking about is centrifugal force. If these masses are rotating, there will be three types of centrifugal force, three centrifugal forces. M1 R1 omega square. Let me say it is having a angular velocity. It is rotating with an angular velocity of omega. Then you will have M2 R2 omega square, and you are going to have M3 R3 omega square. So these are the three forces we are talking about. So if the system of mass is in static balance, then sum of all these three forces will be equal to 0. Sum of all the three forces will be equal to 0. Or simply we can say, for static balance, for static balance, sum of force should be equal to 0. So I can write M1 R1 omega square plus M2 R2 omega square plus M3 R. Definitely vectors, right? You have to do vector sign. Right? You have to do vector sign. Okay, should be equal to 0. Now, if you can see, omega square is common everywhere, so I can cancel omega square. I can simply write the equation as M1 R1 plus M2 R2 plus M3 R3 should be equal to 0. Now, numerically, they might not be equal to 0. You have to consider the vector, right? You must be considering vector. So, how to go about this? How to find out? Because numerically, M1 R1, M2 R2, M3 R3 might not be 0, right? So how to go about? So you can do it mathematically or you can do it graphically. If you want to do it mathematically, means you have to take the cos components, m1 r1 cos theta 1 plus m2 r2 cos theta 2 plus m3 r3 cos theta 3 equal to 0. This will be one equation. Then the other equation will be m1 r1 sin theta 1 plus m2 r2 sin theta 2 plus m3 r3 sin theta 3 equal to 0. Right? This is the one way, right? And what is the next way? The next way is by drawing graph. If you want to see that it is 0, so if you can, the three forces M1 R1 M2 R2 M3 R3 will form a closed triangle. So this is, let me say, M1 R1, then in this direction it is M2 R2, and finally this is M3 R3. So all the three forces are going to form a closed triangle. All the three forces are going to form a closed triangle. If it is a closed triangle, then definitely the sum of all three forces is equal to 0. That is a known thing. Now, what if there is static balance is not zero. What if summation of forces not equal to zero? Summation of forces is, let me say, not equal to zero. Then we have to add a mass. If summation of force is not equal to zero, then we have to add another mass at some angle and some distance so that the overall center of mass lies in the axis of rotation. Right? Again, there will be two equations, right? Two variables. Okay? There can, in total, there can be three variables: mass, radius, and angle. Any one will be given to you. We will have two equations to form. What are the two equations? Again, we can write. Suppose, let me say we are adding a mass. Let me say we are adding a mass. Let me say this is a mass. Okay. Let me say we are adding a mass M4, or let me say MC, or M4. We are leading a mass M4 at an angle of let me say theta 4, and at a radius of R4. So what we can write? We can write we can write the equation as M1 R1 plus M2 R2. Again, this is a vector sum, plus M3 R3 plus M4 R4 equal to 0. Right? Equal to 0. Right? Now, because after addition of the fourth mass, now the system of masses should be now in static balance. Right? There will be two equations from here. There will be two equations from here. One is the cos theta equation, and is the other one is the sin theta equation. So two equations, because either of M4 or either one, either M4 will not be known, yeah, or R4 will not be known, or your theta 4 will not be known, right? Two out of the three variables will not be known, right? You'll have two equations, one cos theta equation and one sin theta equation. You can easily solve out for two variables. No, not easily. I really consider this not easily. So questions from static balancing is generally formed, right? Where the questions will be simple, because with this concept you will require the use of calculator, and it is not possible to do it in a easy manner. Right? This becomes a subjective questions. In fact, this becomes a subjective questions. So questions, if you get, right, first of all, what you are going to get, what is the meaning of static balancing? Static balancing means summation of forces equal to 0. Right? Summation of force equal to 0. Right? When is static balancing required? If the combined mass center does not lie on the axis of rotation. This kind of small questions definitely can be asked. This kind of small questions definitely asked can be asked, right? And also remember, static balancing is done for a system of mass which is rotating about on a single plane. System of mass, which is a system of rotating mass in a single plane. In a single plane. Okay, so let us do a question. Let us do a question. You'll get to understand in a much better way. Okay, let us do a question to understand it much better way. Now, three masses are connected to a rotating shaft supported on a bearing A and B. Okay, this is the shaft. So this is bearing A, this is bearing B, as shown in the figure. The system is in space where the gravitational force is absent. Okay, mg is absent. Neglect the mass of the shaft and rod connecting the masses. Means mass of the shafts and the rod shaft and the rod connecting the masses has to be ignored. For M1 is equal to 10 kg. So this is M1. If you see, these are two different views. Right? You can say this is the front, this is the side view. Right? M1 is given to be 10 kg. M2 is given to be 5 kg. M3 is given to be 2.5 kg. And the distance, that is R1 is 0.1 meter, 0.2 meter, R2 is 0.2 meter, and R3 is 0.4. And the angular speed is also given, but angular speed will not be required. The magnitude of bearing reaction, yes, for that definitely, if you want to find out what is the unbalanced force, we'll have to use omega. Now, Now you can approach it in a traditional method by forming equations that will be very lengthy. So always try to avoid it. So if you want to avoid it, you have to solve it by some other method. You'll have to look for hints. You'll have to look for hints. Now here the greatest hint is the angles are 120 degree. If you can see the angles are 120 degree. If the angles are 120 degree, the possibility of forming an equilateral triangle is very high. Is very high. So what? Let us do one thing. Let us calculate M1 R1, M2 R2, and M3 R3. If you if you try to find out, okay, we'll do it here. We'll do it here, or you can do it here also, no issue. What is M1 R1? M1 R1, I can say M1 R1 is 10 into 0.1. 10 into 0.1, that is equal to 1. And if you want to write the unit also, so it will be kg meter. What is M2 R2? M2 R2 is 5 into 0.2. Okay, so this is also 1 kg meter. And what is M3 R3? M3 R3, this is equal to M3 is given to be 2.5 and radius is 0.4. This is also is equal to 1 kg meter. So you can see the three forces are equal. All the three centrifugal forces will be equal because omega is constant everywhere, and also they are aligned at a angle of 120 degrees. So if you arrange it, M1 R1, M2 R2, M3 R3, it is going to form an equilateral triangle. It is going to form an equilateral triangle. So if it is an equilateral triangle, if it is an equilateral triangle, so what will be the summation of force? The summation of force is 0. So what does it mean? The system of rotating mass is already in static balance. In static balance. Why? Because summation of all the forces is equal to 0. So what will be the magnitude of bearing reaction? The magnitude of bearing reaction will be 0. The magnitude of bearing reaction will be 0. So you have to look for such kind of tricks. You have to look for such kind of tricks. Otherwise, if you try to solve it in a traditional method, it is going to be very long, and also also you'll not be able to find the answer easily. Right? It will take up a lot of your time, and that is what you cannot afford to do in an competitive exam. Okay, so now let us go on to dynamic balancing. That is what we have seen was static balancing. Now let us go into dynamic balancing. Now dynamic balancing is step ahead of static balancing. In static balancing, we have done only summation of force equal to 0. In dynamic balancing, we have to do not just summation of force equal to 0, that has to be ensured first, and after that you have to see that the summation of moment should also be 0. So why it is required? Because here the system of masses are not rotating in the same plane. There are two system of masses rotating in two different planes. So a couple is generated. So this is the difference between static balancing and dynamic balancing. In static balancing, we are trying to balance a system of rotating masses which is in the same plane. So there is no couple. But here, if we are trying to balance a system of rotating masses, right, where the rotating masses are in two different planes. So a couple will also be generated. So the foremost question, objective question that can be asked is, for static balancing, it is only summation of force, but dynamic balancing, you have to do both summation of force equal to 0 force. You have to ensure only when it is statically balanced, there can be a dynamic balancing, right? Plus summation of moment should also be equal to 0. So this is basically dynamic balancing. The second point, it is the system of masses are not rotating in the same plane. So they can be unbalanced forces and also unbalanced couple. So we'll try to equations are almost same, like you have done it for summation of forces equal to 0. Then similarly, you'll have to do summation of moment equal to 0. Equations are almost same. Will not go through the equations. It will not be very important with respect to your exam. Now, for gate exam, you might have to study, but not for this exam. So we'll directly deal with a question. We'll directly deal with a question. Please remember, these are important questions. This is something which has been asked in engineering service, and this is also asked in some of the PSU exams, right? So these are two different questions that I've already dealt with. Now let us deal with a numerical problem, which will help you understand the overall concept properly. Okay, so let us see what is there in the question. Two masses M are attached opposite to the side of a rigid rotating shaft in a vertical plane. Okay, so this is mass M, this is mass M. They're attached opposite sides. Another pair of equal masses M1 attached to the opposite sides of the shaft in the vertical plane is shown in the figure. So this is talking about mass M1. Consider M is equal to 1 kg. This mass M is equal to 1 kg. E is equal to 50 mm, 50 mm. E is equal to 50 mm. E1 is equal to 20 mm. So these dimensions are given. B is equal to 0.3, A is equal to 2, A1 is equal to 2.5. For the system to be dynamically balanced, M1 should be equal to. So this is a classic question of dynamic balancing. Let us see. The first thing that you have to see is that summation of forces should be equal to 0. Summation of forces should be equal to 0. Summation of forces should be equal to 0. So this is very simple to verify here, because you see there is a centrifugal force, and the masses are attached to the opposite side. So definitely whatever centrifugal force this is going to create, it will be cancelled by this. Whatever centrifugal force M1 is going to produce, it will be cancelled by the M1 mass attached exactly at the same radius, but in the opposite side, right? So you can analyze from here that this is statically balanced. This system is statically balanced. The system is statically balanced, because if I write it full, even if I write it full, so this is going to produce M E omega square. This is also going to produce M E omega square. Not writing omega square because omega square will be everywhere. This is also going to produce M1 E1 omega square, and this is also going to produce M2 E2 omega square. So the system of masses is already in static balance. Already in static balance. Already in static balance. The system of mass is already in static balance. Now what? We have to go into the second part, that is summation of moments should be equal to 0. Summation of moments should also be equal to 0. So if summation of moment, if you check summation of moments, now it's a very, very important point to remember that for moment, calculating moment, you always require a plane, an axis, or you can say a line, right? So if reference plane is required, about which you will calculate all the distance. Now, what is the reference plane here? What we can consider the reference plane as this. Sorry, let me say this is the reference plane. You can consider anywhere here. You don't have any much restriction. You can consider the reference plane anywhere. Generally, reference plane, if there are more than one unknowns, generally we'll consider the reference plane passing through one of the unknowns, because when you're calculating the moment, you require a distance. So the unknown, the distance will be 0, so it will get cancelled out. So let me say this is the reference plane. Reference plane. So now you have know the reference plane. So what we are going to do is, we are going to calculate the moments. So there will be 3 moments, right? I can write the first moment as ME. Omega square will be there. Again, it will get cancelled out from everywhere, so I'm not writing it. M into E into B. Right, let me write it at the top. M into E into B. So this is for the first one. So this is the anti-clockwise, right? So I'm considering anti-clockwise is positive. And which one else is anti-clockwise? This one is anti-clockwise plus M1 E1 into A plus B into A plus B. M1 E1 into A plus B. Sorry, it's not A plus B, it is equal to A1. Sorry, it is equal to A1 into A1. And you have minus because this will be clockwise movement. This is creating a clockwise movement. M into E, M into E, M into E into A plus B, A plus B equal to 0. You can see A plus B equal to 0. So if you want to calculate from here, I can see that something is getting cancelled. MEB and MEB will get cancelled. So you need to take out, find out M1. You need to find out M1. So M1 I can write it as M1 is equal to MEA divided by M1 E1, M1 E1. So M1 is equal to, if you substitute the values, value of M is equal to 1, E is equal to 50 mm means 0.05 mm, A is equal to 2 divided by E1 M, sorry, not E1, M1 E1, it is E1 A1. So E1 is 0.02, 0.02 you can see into A1 is 2.5. So if you see from here, calculate, it will go 2 will cancel out, 2.5, 5 divided 2.5, the value of M1 is equal to 2 kg. The value of M1 is equal to 2 kg. The value of M1 is equal to 2 kg. So I hope it is clear to all of you. I hope it is clear to all of you. So here we'll finish off balancing and we'll be starting the last chapter, that is cams and followers. We'll be starting the last lecture, that is cams and followers. Okay, let us start cams and followers. Let us start cams and followers. So what exactly is a cam? A cam is a mechanical element which is used to impart desired motion to a follower by direct contact. So generally you will see an arrangement like this. So this is kind of a cam. It will be hinged eccentrically. Generally it is hinged eccentrically. So this is the cam, and then you will have a follower. Then you will have a follower. You'll have a follower which will be in direct contact with the cam. Which will be in direct contact with the cam. So the follower will not be fixed, but its motion will be constrained. Its motion will be constrained. There's something like this. So this is the follower. This is the follower. And this is the cam. This is the cam. So the cam is going to rotate. The cam will rotate, right? It could be clockwise, it could be anti-clockwise, as per requirement. So this is the profile of the cam, right? Profile of the cam. So this profile will be traced by the follower. This profile will be traced by the follower, right? So what will the follower do? Follower will move up and down. The follower will move up and down based on the profile. How does the profile wants? Right? So desired motion is imparted to the follower by the cam through a direct contact. Now you can see here it is a point contact. There's a point contact. So this is also a higher peer. Point contact. So this is also called, this is also in the category of higher pair. Now in place of the in place of the uh, pointed contact, we can also use rollers, because knife edge followers, right? What will happen? It will cause a lot of wear and tear. So we can also use rollers in place of knife edge followers, right? This is a roller. This is a roller. Okay. So here the cam is the driver. This is the driver. The follower is the driven, right? And there will be a frame. For example, this is the frame which is supporting the cam, and this is the frame which is supporting the follower. So there will be a frame which supports and guides the cam, and supports the cam and guides the follower, right? So these are the three basic parts of a cam and follower. So what is the degree of freedom of a cam and follower? Degree of freedom of the cam and follower, you can find out it is equal to 1. If you use the degree of freedom equation, if you use the degree of freedom equation, we know that F is equal to 3L minus 1 minus 2J minus H. So how many members are there? Frame, cam, follower. So there are 3 links minus 2 into how many binary joints are there? There is one binary joint here, one binary joint here, right? So 2 into 2 minus one higher pair, because of the point contact. So 3 to the 6 minus 4 minus 1, that is equal to 1. So what is the degree of freedom of cam and follower? Degree of freedom of cam and follower is equal to 1. So we have already seen earlier, cams and follower is the first mechanism that can be formed, right? So if you are asked what is the minimum number of members required to form a mechanism, it is 3. You can see the cam, the follower, and the frame. It has 3 parts, right? The cam, the follower, and the frame. 3 parts, right? But also it contains a higher pair. It also contains a higher pair. So minimum number of members required to form a machine is 3. That is cam and follower. Now, if you are asked if there should not be any higher pair, minimum number of members required to form a machine or mechanism without any higher pair or with only lower pairs, that is 4. That is, you have seen the 4-bar mechanism. Okay, so cams and followers, it will not be required. Means what I mean to say, uh, we will not be able to cover it in very much detail, right? So we will see, we'll attack the objective questions first. We will get to learn the main, this is the main point, we'll get to learn all the cam terminologies, right? We'll try to attack all the cam terminologies. The first is a base circle, right? So it is the minimum radius circle touching the cam profile. So which is the cam profile? This is the cam profile, right? So it is hinged somewhere here. So the base circle is the minimum radius circle which is touching the cam profile, something like this. The minimum, it has to be the minimum radius circle which is touching the cam profile. So this is the base circle, right? So I've shown it here. I've shown it here. So you can see the one marked by the black is the cam profile. This is the cam profile. Okay, this is the cam profile, you can see, right? And this is the base circle, the blue one, right? The minimum radius circle which is touching the cam profile. Next is the trace point. What is trace point? The point on the follower which is required to trace the cam profile. The point on the follower which is required to trace the cam profile. So till possible, let me show you here. Let me say I'm using a roller follower. So this is the point. This is the point which is going to trace the cam profile, right? Because the cam, the steepness, the slope, ascent, descent, well, everything will be traced by this point. Everything will be traced by this point, right? So that's, this point is nothing else but the, this point, sorry, this point is nothing else but the trace point. This point is nothing else but the trace point. Okay. Now next is the pitch curve. Next is the pitch curve. Okay. If the cam is fixed and a follower is made to move around the cam, the path traced by the trace point is called the pitch curve. So the path traced. See all these definitions you'll have to remember. Right? So basically, the path traced by the trace point is the pitch curve. Right? So this is the path that will be traced by the pitch point. So this is nothing else but the pitch curve. And then you have prime circle. What is prime circle? It is the minimum radius circle which touches the pitch curve. Now it is if I keep on drawing, so it becomes very hectic. So the last thing that I'm drawing. So what is the prime circle? Prime circle is the minimum radius circle which touches the pitch. You can see the green color circle. It touches the pitch curve. Then you have pressure angle. What is pressure angle? The angle between line of action and line perpendicular to the pitch curve. The line of action is the line perpendicular to the pitch curve and line of motion of the follower. Pressure angle represents the steepness of the cam profile. Please remember, pressure angle represents the steepness of the cam profile. High pressure angle is not desired as it might jam the cam profile. So how to show? How to show the pitch? How to show the pressure angle? So if you draw A, see, it is clearly mentioned. If you go through this line, I think most of the questions will be able to answer, right? So it is a line perpendicular to the pitch curve and the motion of the follower. So which is the pitch curve? You can see this is the pitch curve. A line, you can draw a line perpendicular to the pitch curve, and then you have the motion of the follower. So the angle between them is nothing else but the pressure angle phi. Okay? This is nothing else but the pressure angle. Pressure angle. This is nothing else but the pressure angle. What else? What else do we have? We have pitch point. The point on the pitch curve where pressure angle is maximum. What is pitch point? Pitch point is the point on the pitch curve where the pressure angle is maximum. Right? There may be more than one pitch point. Right? Then you have the pitch circle. You have the pitch circle. See, the pitch curve and pitch circle, they are two different things. There is a pitch curve and the pitch circle. You have to remember there are two different things. So, what is pitch circle? It is a circle having center of the cam. Cam center is the center of the circle and passing through all the pitch points. Passing through all the pitch points means passing through all the points where the pressure angle is maximum. Then you have angle of ascent, angle turned by the cam when the follower rises. You have angle of descent, angle turned by the cam when the follower moves down. Then you have angle of dwell, angle turned by the cam when the follower is stationary. So this 10 points is what you will have to remember. If you remember this 10 points, it is good. It is good. It will be good if you can remember this 10 points. Okay, so I've shown it in the diagram. Along with the diagram, you can remember these points. So what apart from this, motion of the follower, we'll see the motion of the follower. What are the different motions of the follower possible? The different motions of the follower possible are simple harmonic motion, which is used for follower means this one, right? What kind of motion is possible? This is definitely dependent on the cam profile. How we design the cam profile, similar motion will be imparted to the follower, right? So what are the different motions possible? Simple harmonic motion. This is generally used for low speed cam. Please remember all these points. Constant acceleration, deceleration profile motion. This is also parabolic in nature. It is used for medium speed cams, right? Constant velocity, right? It is not suitable for practical point of view. You will not use constant velocity. Cyclodal. It is a what is cyclodal? A locus of a point on a circle rolling on a straight line. It is ideal for high speed. So questions like this, which follower motion you are going to use for high speed, which follower motion you are going to use for low speed or medium speed, that kind of question might be asked. Right? Now, generally question on the types of follower according to the line of motion, you might see. So what is that? What is that? A radial follower is a follower which is passing through the, if the motion of the follower line is passing through the, if the follower line is passing through the, just hold on. Sorry. So what exactly is a radial follower? I'll show it to a good diagram. Proper diagram. I'll show you the proper diagram. So suppose this is the cam. Let me say this is the cam. Okay. So suppose let me say the cam is fixed here. So now if the line of motion of the follower passes through the cam center, if the line of motion of the follower means if the line of motion, the follower is somewhere here, it passes through the cam center, then it is called a radial follower. If the line of motion of the follower is not passing through the cam, it is somewhere else. Suppose the follower is not located just above the center of the cam but somewhere else, it is known as offset follower. So that's all, my dear friends. I wish all of you best of luck for your exam.